In the previous classes, already we have familiar something with that is known as the matrix. Now, what is the matrix? How the matrices are formed? Then what are the different types of matrices? Then we have the matrix operations, that is addition. According to these operation, matrix addition, their properties. Then the matrix multiplication with a scalar number, and according to these their properties. Then the matrix product or the matrix multiplication with another matrix, their properties. Transpose matrix, and according to transpose matrix, the symmetric and skew-symmetric matrix. Now, after that, whatever we are proceeding to the matrices, there is another term is an important, and that one is known as the determinant. The determinant is now required to for other matrices. Okay, what is the determinant? Now, determinant is coming from the matrix. The very first one, matrix may be of different orders. Matrix may be of different orders. That means it may be also rectangular. It may be also of square. That means the number of row and number of columns are equal. In the case of determinant, that is always coming from the square matrix. That means from the rectangular matrix, we cannot find out the determinant. Now the second one, what is a determinant? Matrix is a group of numbers or group of elements or group of values that is arranged in the row and column type. In the case of determinant, that is only one value. Determinant, although represent, look like a matrix, there are different type of elements, but practically the determinant represent only one value, and that is called the value of the determinant. Next one, matrix is represented by the parenthesis or the third bracket, or the simply it is called as a bracket. Determinant are represented by two bars, or we may say it is a modular sign, using modular sign. Okay, let's check what is happening here with the matrix and the determinant. Suppose we have a matrix A, as we are representing it with the parenthesis, so that is a matrix A11, A12, A13, A21, A22, A23. That means the order is 2 cross 3. So there would be no determinant for that matrix, because it is not a square matrix. Next, we are proceeding with another matrix, that is A. Suppose A11, A12, A21, A22. Hence, 2 cross 2, that means a square matrix. The determinant is possible. Okay, and how it is represented? The representation is of the determinant like D, E, T in parenthesis, that is A. That means that is the determinant of A. That is the first representation. Or we can represent using very small notation, that is like that. That is the determinant of the matrix A. And if using the values or the elements, we can say A11, A12, A21, A22. That is the
Sir,
determinant. হ্যাঁ বলো।
বলছি ওই ডিটারমিনেন্ট এটাকে যে ব্র্যাকেটে লিখেছেন স্যার, ওটাকে যদি শর্টে যদি লিখতে বা এক ওয়ার্ডে যদি লিখতে তাহলে ওই বার্সের মধ্যে লিখবো।
কোশ্চেনটা বোঝা গেল না।
স্যার আপনি যে ডিটারমিনেন্ট এ ব্র্যাকেটে লিখেছেন তার নিচে লিখেছেন এ বার্সের মধ্যে, স্যার মডসের মধ্যে যে লিখেছেন স্যার, তো ওটা যদি ডিটারমিনেন্ট এ যদি লিখতে জাস্ট ওটা লিখে দিলে হয়ে যাবে স্যার।
হ্যাঁ, দ্যাট ইজ দ্য স্মল রিপ্রেজেন্টেশন, কিন্তু প্র্যাকটিক্যালি এটা জাস্ট লেফট হ্যান্ড সাইডে একটা নোটেশন। আমার যখন ক্যালকুলেট করতে হবে তখন তো ইউজিং ভ্যালু, দ্যাট মিনস দ্যাট ওয়ান ইজ দ্য ইম্পর্টেন্ট থিং। আমাকে তো ক্যালকুলেট করতে হবে না, আমি তো শুধু লিখে দিলে নাম হবে না, আমাকে ক্যালকুলেট করতে হবে। তখন আমাকে ক্যালকুলেশন করার জন্য কিন্তু এইগুলো লাগবেই।
হ্যাঁ স্যার।
ওকে, নেক্সট ওয়ান, হাউ টু ফাইন্ড আউট দ্য ভ্যালু নাও। Just start from the top A11 element, then multiply it with diagonal. That means A11 into A22, then the minus sign or the subtraction with that one. That means A12 into A21 or A21 into A12. Once again, the value is A11, A22 minus A21, A12. That is the case of a 2 cross 2 determinant or of order 2. Let's an example. Suppose we have a determinant like that: 1, 2, 4, minus 5. Okay, that is the value. So what is the value determinant? 1 into minus 5 minus 2 into 4, or minus 5 minus 8, or minus 13. So that one is the value of the determinant. Okay, if we want to name it, we can say that one as like that, or we can say determinant of A is equal to that one. Okay, another small one. Suppose minus 1, minus 2, 3, 4. So that one is like minus 1 into 3 minus 2 into 4, or minus 3 minus of minus, that means plus 8, that means plus 5. That is the value of the determinant. It now okay?
Yes, okay, sir.
Okay. Suppose we have a 1 cross 1 matrix. Suppose A is equal to like that, A11. So what is the determinant of, that is a square matrix. So what is the determinant of A? Or like that. So that must be A11. Okay. Suppose A is equal to minus 2. So determinant of A is equal to determinant of A is equal to determinant of minus 2 is equal to minus 2. That is not the modulus value. Once again, that is not the modulus value. That is a modular like sign, 2 bars, but not modulus or the absolute value. Same as if we have 2. So the determinant of A is equal to determinant of A is equal to determinant of plus 2 is equal to plus 2. So that one is an important thing, that is not the modulus value, not the modulus value, that is simply a value. So 2 cross 2, 1 cross 1. Next, the higher order. Suppose very first one, we are proceeding with a 3 cross 3. 3 cross 3 determinant value. And before the 3 cross 3 determinant, we have to know about another two terms. The first one is called the minor of any element, and another one is called the cofactor of any element. So the very first one, what is a minor? Suppose we have a 3 cross 3 determinant. At the first time, we are writing 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Always remember, minor of any element means whatever the elements are present in the determinant. How many numbers of elements are present in the element? For each and every element, there is a minor. Okay. Suppose we are considering very first time the minor of 1. So we are writing it as minor of 1. What is the minor of 1? At that moment, just think at which row the element is residing and at which column the element is residing. Element 1 is residing at the row number 1. It is residing at the column number 1. So remove these two row and column. Whatever the rest are there, that is the minor of that particular element. So that means minor of 1 is 5, 6, 8, 9. Once again, suppose for minor of 6, that element. Okay. So once again, we are proceeding with whichever row it is containing. It is containing the row 2nd, it is containing the column 3rd. Just remove that for particular element, we have to find out the minor. So when we are removing this, we are getting the values as 1, 2, 7, 8. Okay. So there are practically 9 elements, and for each and every element, there is a minor. Let us suppose once again another determinant that is of more than order 3. Suppose order 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Suppose we want to find out the minor of 4, the element 4. So that means that one. So here we are removing its row residing, its column residing. So its minor is now 5, 6, 7, 9, 10, 11, 13, 14, 15. Suppose another one element. Suppose we want to find out the minor of 10. Okay, so minor of the element 10, that means that one. So once again,
5, 6, 7, 13, 14, 15. 1, 2, 3, 4.
Once again, remove the row it is coincide and it is the column. So we are getting 1, 3, 4, 5, 7, 8, and 13, 15, 16. Is that clear about minor?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Next one is the cofactor. Cofactor is connected with minor. Any question?
Yes, sir. So in case of 2 cross 2, we don't need to have those minors.
Suppose 2 cross 2, that is, we have a determinant 1, 2, 3, 4. Okay, so what is the minor of 2? Just remove the row it is residing, remove the column it is residing. That means we are finding the minor of 2. So minor of 2 is only 3.
Yes, sir.
Suppose if the question, if there is only 1, so what is the minor of 1? Practically there is no minor of 1 because it is the only one element. There is no other minor. Is that clear now?
Yes, sir.
Okay.
Yes, sir.
Next one, cofactor. Now cofactor is also connected with the minor. Cofactor is connected with minor. The same
Will
determinant.
you please go to the previous page one?
Sorry,
Will you please go to the previous page one?
which one?
The previous page of this one.
The previous page of this one is that.
Okay, sir.
Cofactor of any element. Suppose once again I am proceeding with that minor. Okay, so I am writing minor of, suppose, the element that is 5. Okay, so minor of 5 is equal to 1, 3, 7, 9. Why? Because we have removed the row number 2, column number 2. So 1, 3, 7, 9. That is the minor of 5. But cofactor of 5, that is connected with -1 whole to the power r plus s into its minor. That means 1, 3, 7, 9. Now what is r? What is s? R is the row number where the element resides. Row number where the element resides, and S is the column number where the element resides. Okay, like for 5, in which row it is present? That is
The
5.
second row.
5, or sorry, 2. So row is 2 plus in which column? That is also 2. So -1 whole to the power 4, or that one is also an even number, into its minor is the cofactor of 5. Once again, suppose I am proceeding with the minor of 1. Okay, so what is the cofactor of 1? That would be -1 whole to the power its row plus its column position. Its row position is 1, its column position is 1, into its minor. So that means that is also plus, that is plus into minor, that is plus into minor. Now suppose another one element for 2. Okay, so for 2 I am writing here minor of 2, that is 4, 6, 7, 9. Okay, what is the cofactor of 2? That one is -1 whole to the power its row position, that is the first row, and then plus its column position, it is 2, in the second column and in the first row the element 2 is residing. So minus 1 whole to the power 1 plus 2 into its minor. Its minor is 4, 6, 7, 9. Now minus 1 whole to the power 3. That means minus of 4, 6, 7, 9. If we want to consider minus 4 into 9 minus 6 into 7, that means minus of 36 minus 42. Or we can say that is minus of minus 6. That means plus 6. Originally its cofactor. Okay. Now for 3 cross 4 cross 4. Okay. Suppose that one. Here we are proceeding with the element that is 11. Suppose. So what is the minor of 11? Minor of 11. That one. If we consider that row and that column. So 1, 2, 4.
1, 2, 4, 5, 6, 8, 13,
5,
14,
6,
16.
8 and 13, 14, 16. Very good. That is the minor. But what is the position or the cofactor? So cofactor of 11 is equal to minus 1 whole to the power its position according to row and column. Okay. It is in the third row.
Third row, sir.
It is
Third
in the
column.
third row and
Third row,
third column. Okay. So as usual with minor. Now that one is, that means plus, because minus 1 whole to the power odd. Sorry, even. Okay. So what is happening here? Practically, if we see, there would be a very interesting thing. The first one is giving us plus, second one is minus, third one is plus, fourth one is minus. Then minus, plus, minus, plus. Then plus, minus, plus, minus. Then minus, plus, minus, plus. If we consider here plus, minus, minus, plus, or next one plus, minus, plus, minus. Okay. If we check the values, then once again we have that. Okay. So that one is the thing. How we can find out the minor and cofactor. Proceeding to the finding the value of a determinant. Finding the value of a determinant, which is of higher order, at least starting from order 3. Okay, we have a value. We have a determinant 3, 5, 6, 0, 2, minus 4, 1, 7, 8. Okay. For finding the value of any determinant, we can choose any row or any column. For each and every case, the value of the determinant must be the same. Suppose we are starting with the first row. So what are the elements? 3, 5, 7. Okay, once again, the first row 3, 5, 6. That must be 6, not 7. That is 6. Okay. Then find the minor of 3. Find the minor of 5. Find the minor of 6. The minor of 3 is 2, minus 4, 7, 8. Minor of 5, that is 0, minus 4, 1, 8. Minor of 6, that is 0, 2, 1, 7. Then use the cofactor values. That means for 3, minus 1 whole to the power its row position plus its column position. For 5, minus 1 whole to the power its row position plus its column position. For 6, minus 1 whole to the power its row position plus its column position. Obviously, minus 1 whole to the power 2, that is plus. For minus 1 whole to the power 3, the value is minus. Minus 1 whole to the power 4, the value is plus. So practically that is plus 3 into, at that moment I am multiplying or finding the value of the determinant 2 cross 2. So that is 2 into 8 minus of minus 4 into 7. Always very cautious with the signs. That is minus of minus 4 into 7. Then the second one is minus 5 into 0 into 8 minus of minus 4 into 1. Then plus 6 into 0 into 7 minus 1 into 2 or 2 into 1. So what are the values? At that moment, that is 3 into 16 plus, because minus and minus, that is plus 28 minus 5 into, that is minus and minus, that is 0. So minus of minus, that is plus, that is 4 plus 6 once again, that is 0 minus 2. So that is minus 2. So that one is becoming 3 into 36 minus 20 minus 12, or that one is 132 minus 20 minus 12, or the result is 100. That is how we can find out the value of the determinant using any row or any column. At that moment, we have used the first row only.
So it will be 3 into 34.
Which one?
3 into 16 plus 20, 28. That
Oh,
one will
sorry.
be 3 into
34. 34. 34. Oh.
The 44.
Sir, 44. Already I know the value 100. That's why minus 32 I have done. But that is the 44, right? Okay. Suppose we are using at that moment any other row or any other column. The same determinant. Suppose 3, 5, 6, 0, 2, minus 4, 1, 7, 8. Normally we use the first row. Here I am changing the first row to any other row. Suppose thus using second row. Okay, so using second row, 0, 2, minus 4. The element was minus 4, not about minus or plus. That element is minus 4. So 0 into its minor. Remove that row, remove that column. So that is 5, 6, 7, 8. Then minor of 2, that is 3, 6, 1, 8. Then minor of minus 4, that is 3, 5, 1, 7. Okay. Now we are proceeding to its plus or minus. For 0, minus 1 whole to the power second row plus first column, minus 1 whole to the power second row second column. For minus 4, minus 1, its position second row plus third column. So that one is becoming minus, that one is becoming plus, that one is becoming minus of minus 4. Okay, minus of minus. So it would be transformed into plus. Okay, so that one minus as the first one is 0, but I am once again finding the value. 5 into 8 minus 42. Okay, that means 40 minus 42. Plus 2 into 3 into 8, that is 24, minus 6. Now, that is minus of minus 4. That means once again that is plus 4 into 21 minus 5. That means 3 into 7 minus 5 into 1. So first one is 0. Second one, 2 into, that is 18, plus 4 into, that is 16. Okay, so that is 36 plus 64. And the result is 100 as usual. Okay, suppose we are using the second column at that moment. Okay, and at that moment we are not using minus plus something. Just remember plus minus plus minus plus minus plus minus plus minus plus minus plus minus, like that. Okay, then the next would be minus. So we are using directly here plus 5 into, directly I am calculating 3 into 8 minus 1 into 6, then minus 2. Sorry, the very first one was the minus 5. Now that one is the plus 2 into, once again পুরোটাই তো ভুল করছি রে, কেউ কিছু বলছিসও না। minus 5 into that row, that column. So that means 0 into 8 minus 1 into minus 4. Okay, then the next one plus 2, that must be 3 into 8 minus 1 into 6, and then the minus 7, and here that must be 3 into minus 4 minus 6 into 0. Okay, the result must be 100. So that is minus 5 into 0 plus 4 plus 2 into, that is 24 minus 6 minus 7 into, that is minus 12, just that one. Okay, so that one is now minus 20. That one is 2 into 18, that means 36, plus 84, because minus of minus plus 84. So the result is 1 minus 20 plus 120. That means 100. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So for any determinant, value of the determinant, we can use any row or any column. There would be no problem.
Sir, matrix টা 4 cross 4 হলে?
Same as like if there is a 4 cross 4 matrix, suppose 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so just we are not using here the plus minus thing, that is we are writing directly, and we are using suppose the very first one element. Okay, first one row, sorry. So that would be 1 plus 1 into its minor. What is its minor? 6 7 8 10 11 12 14 15 16. Then minus 2 into its minor, 5 7 8 9 11 12 13 15 16. Then plus 3, its minor, that means 5 6 8 9 10 12 13, 14, 16. Then minus 4, it's minor 5, 6, 7, 9, 10, 11, 13, 14, 15. Now that is a 3 cross 3. Each and every minor is a 3 cross 3. We can once again find out the value using the determinant how we have found earlier, that is 3 cross 3. So next we are proceeding with some properties of the determinant. Properties of the determinant. Anyone who has the mathematics in class 12 or have the knowledge of determinant something, can you say what is the value of that one? Anyone? Without any calculation.
Zero.
Why?
কারণ ফার্স্ট রো আর ফার্স্ট কলামটার সাথে থার্ড রো আর ওই কলামটাকে সেম আসছে যেহেতু
Not first
row
column,
1 and row
first,
3.
right?
Sorry, row 1 and row 3.
First
row and third row second.
If in any determinant we have two rows or two columns have the same element, the value of the determinant is 0. Here we can check row 1 have the values or the elements 1, 2, 3. The row 3 have the same elements 1, 2, 3. So obviously without any calculation we can say the value of the determinant is 0. Suppose we have a very big order determinant like that 1, 2, 3, 4, 5, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1, 2, 3, 4, 5. So that is a 5 cross 5. But here we can check column number 1 elements and column number 2 elements both have the same value, same elements. So sorry, column 5, column 5. Okay, so it has the deterministic value that is 0. That is the very simple way to find out the value of those one. So the value of the determinant is equal to 0 at that moment. How we can find out? Simply, now if any two rows or any two columns for any order, if both are equal, the value is 0. That is the first property. Now the second property. Second property, suppose we have the very first one determinant we have already found, that is 3, 5, 6, 0, 2, minus 4, 1, 7, 8. Already it has the value that is 100. Can anyone say what is the value of that one?
Sir, minus 100.
Right. The answer is minus 100, not plus 100. Why? If we interchange any two rows or any two columns of any determinant, the value remains same. The value remains same, but the sign changes. Okay, suppose the very first one. Here already whatever we have done, now column 1 and column 2 has been interchanged. Okay, at first that was our column 1, that one was our column 2. Now that is our column 2, that is our column 1. So the value remains same, but the sign changes. At first that was as plus, sign changes. Okay, suppose once again, that is according to column we have done. Suppose according to row. Okay, so from here, suppose 1, 7, 8, then 0, 2, -4, 3, 5, 6. What is the value? Already the row 1 has been changed into row 3 and row 3 has been interchanged into row 1. So at first the value was plus 100, but only one interchange, so the value is now minus 100. Okay, after that, suppose once again we are interchanging row 1 to row 2. Row 2 is now row 1, row 1 is now row 2. At first that was row 1 interchanging with row 3. So that one is becoming 0, 2, -4, 1, 7, 8, 3, 5, 6. So before that, the value was -100. So sign is interchanging because one interchange of row, so that is minus of -100, that is +100. Clear?
Yes, sir.
Okay. Suppose once again I am interchanging and you have to give the value. Okay. What is the value of that determinant? What is the value of that determinant?
So +100.
That is +100. Why?
বিকজ স্যার তিনখানা তিনবার চেঞ্জ হয়েছে, দুবার হলে মানে প্রথমে মাইনাস দেন
3 times or 2 times?
2 টাইমস হয়েছে, একবার ইন্টারচেঞ্জ তারপর আবার ইন্টারচেঞ্জ করা হয়েছে।
Okay, at first we have interchanged the row column 1 to column 3. Okay, so first column 1 to column 3, that means 6. I am just writing the first row, 6, 5, 3. Okay, then once again we have interchanged the column 2 and column 1, so that means it is becoming 5, 6, 3. So that one, so two interchanges. For the first one, that is from +100 to -100, then another interchange, so that is from -100 to +100. So the result is +100, two interchange. Okay, another one it may possible, that is we can also consider that interchange within a single determinant. The first one is a row interchange, then column, or the first one is a column, or the second one is a row. And so many times, there is infinite number of times we can interchange the row and column. There would be no problem. So the very first one, suppose we are interchanging column 1 to column 2. So that is becoming 5, 2, 7, 3, 0, 1, 6, minus 4, 8. So it is now minus 100. Now once again, I am interchanging row 1 and row 3. So it is now 718, 536, 20, minus 4. That is minus 100. So now that is plus 100. Okay, clear?
Yes, sir.
Yes, sir.
Say. हाँ बोलो. Okay. Another one thing we can proceed with, that is the third property. Suppose we have the same determinant 3, 5, 6, 0, 2, minus 4, 1, 7, 8. Okay, the value is 100. What is the value of that one? Anyone?
স্যার সেম থাকবে, রো আর কলামটাকে ইন্টারচেঞ্জ করলে ভ্যালুটা সেম থাকবে।
Because here that one is nothing, that is the transpose of the determinant. Transpose of the determinant. And when we transpose any determinant, the value remain same. Just for your easiness, whatever is the plus, minus, plus, check plus, minus, plus, minus, plus, minus, plus, minus, plus. Now that is becoming the same as plus, minus, plus. So without first row, we can also use with the first column. And when we have that element 3, after transpose, the minor remain the same. Check. For the before transpose, that is 2 minus 4, 7, 8. Here is also 2 minus 4, 7, 8. The value remains same. The first one was that one. Second one was that one. Okay. So 2 into 8 minus 7 into minus 4 was there. Okay. So that is 18, sorry, 16. 16 plus 28. That means, once again, that is 44. Okay. That is 44. Once again, we can check it also here. 2 into 8 minus of minus 4 into 7. That means 16 plus 28 or 44. Okay. Check with the element that is 0 when we are using, or plus 1, suppose that element. That element is now here. Its minor was 5, 6, 2 minus 4. Okay. So 5 into minus 4 minus 6 into 2. So that means that was minus 20, minus 12, minus 32 for 1. That is plus. That is plus. Now it's minor. That one. That means 5 into minus 4 minus 6 into 2, or minus 20, minus 12, or minus 32. One as the cofactor plus 1, that in also has plus 1. So in that way, we can say the transpose of the determinant remain the same value.